Hi, everybody. All right, so this is just day 2 of the section 13.4. If we were doing this like in class, I would give a second day where we would just spend going over the homework, just question by question, and then like just giving it some time to digest, and then you just work on the homework. So that's all I'm going to do. I'm going to give a video going over the homework and just going through question by question, line by line, because I get this section is a little weird. That's what we're doing on this lesson. Make sure you have your homework out. You can follow along and go over it, and the quiz for 13.1 to 13.4 is going to be next week. All right. See ya. All right, here we go. All right, let's start here. Find all possible values of the expression. Notice that it doesn't say what to use. So I'd be okay if you used degrees or radians, doesn't really matter. So unit circles at the ready. Cosine is 1, so x value is 1. There's actually only one spot right there. That's it, right there. Okay, so where is that? That's 0 degrees. If you wanted to say, we'd have to say plus 360 n, or if you wanted to say 0 radians plus 2 pi n, that'd be fine. So there's actually only one location for that one. Inverse sine of radical 3 over 2. So I'm looking for the y value, and I'm looking for the y value being radical 3 over 2. All right. So the y value being radical 3 over 2. And you know what? I'm gonna shrink this down just like I did in the last video. Okay. So I'm looking for the y value being radical 3 over 2. The y value being radical 3 over 2. Okay, right here. Right, so right here, the y value being radical 3 over 2, right here. Okay, notice that I don't want to choose those. Those are the negatives. Okay, so it's 120 degrees or 60 degrees. 60 or 120. 60 or 120. If you put it into radian mode, that would be pi over 3. Or what would that be? 2 pi over 3, I believe. Let me just double check on that. It's not in my head. Yeah, 2 pi over 3. Okay, so don't forget about the full rotations. Plus 360n, plus 360n, plus 2 pi n, plus 2 pi n, where n is any integer. All right, tangent being -1. So this is very similar to one of the ones that we did in notes, but this is -1, right? So remember that if it's going to be a 1, it's got to be in that 45 family, because that's the only one that has the y over x. That's going to be the same thing over the same thing. That's the only coordinate along the unit circle that has the x and y being the same thing. So it's in the 45 family, but I want it to be negative. They're the only place where tangent ends up negative are the second and fourth quadrants. So in the 45 family, that would be, so this is 90 plus 45, 135? 135 degrees, I believe. Is that right? I always screw that one up. 135 degrees. Yeah, I think that's right. I better go try. 135 degrees. And then plus 360n. And then down here is going to be, what's 315, I think? Plus 360n. I better check on that one. 315. Yeah, 315. Okay. And that is 3 pi over 4 and 7 pi over 4. 3 pi over 4 and 7 pi over 4. Plus 2 pi n plus 2 pi n. All right, so 17, 18, and 19. Okay, now notice that for 19 to 24, they're all capitals, right? They're all capitals. So all restricted domains. Remember, sine is restricted to the first and fourth quadrants, -90 to +90. Let's go over those restrictions real quick. So sine, again, is -90 to +90. Cosine is 0 to 180. And then tangent is going to be -90 to +90. Okay? And remember their radian counterparts, negative pi over 2 to pi over 2, 0 to pi over 2, and then negative pi over 2 to pi over. I'm sorry. Yeah, 0 to pi, excuse me, 0 to pi for cosine, and then negative pi over 2 to pi over 2. All right. All right, so radical 3 over 2. Where is radical 3 over 2 for the y value? Sine is y value, so I want to go with a y value is radical 3 over 2 right here. Didn't I just do that? Didn't I just do that? Didn't I just do that? Yeah, I did just do that. So what's the only one that is in between negative 90 to positive 90? 60 degrees. In radian mode, pi over 3. That's it. Okay. Inverse cosine of negative 1. Well, negative 1. Okay, negative 1, negative 1, negative 1. Where's the x value of negative 1? 180 or pi. Okay, 180 or pi. Okay. Tangent. Okay, now when the tangents are this radical 3 thing, right? Okay, now when the tangents of the radical 3, it's either in the 30 family or the 60 family. You just have to figure out which one. I like to just test it out. If I forget, I like to test it out. So like if I'm looking here and I don't know which one it is, because I know the 30 and the 60 have the radical 3 to it. The tangent is always 1 for the 45 family, but the tangent for the 30 family, if I forget, I just take y and I divide it by x. Okay, y divided by x. Now that would be 1/2 divided by radical 3 over 2. And then so that'd be 1/2 times 2 over radical 3. Canceling out the 2's would be 1 over radical 3 or radical 3 over 3. It is within my 30 family, okay? It is in my 30 family. So we would say 30 degrees. Now, let's take a look at cosine, negative radical 3 over 2. Where is the x value, negative radical 3 over 2? Well, the x value is a negative radical 3 over 2. Right. Yeah. And remember, I know it's right there, but don't look at that one. Cosine is only restricted to first and second. So 150 or 5 pi over 6. 150 or 5 pi over 6. 150 degrees or 5 pi over 6. Okay. Now, tangent being radical 3. So I just worked through the fact that the 30 family is going to have the radical 3 over 3. The tangent, so that means the 60 family is going to have the radical 3 or pi over 3. Oh, I didn't do this one. Sorry. Oops, forgot my radian on there. Okay, where is the inverse sine radical 3? Nowhere, right? If I go to my calculator and I actually have to run that, inverse sine of radical 3, it's going to tell me no solution. Domain error, because it's not within the restricted domain. Can't be possible. Radical 3 is bigger than 1. Whoa. What is radical 3? Radical 3 is something bigger than 1.7. So obviously there's no angle that has a 1.7 y value. All right, let's take a look at 25. I'm going to look. I know that this is the height. The player spikes the ball is 2.44 meters. So that is right here. Okay. So if this is the theta that I want to figure out, this is the opposite, this is the adjacent. So tangent theta, and again, tangent theta is going to be equal to 9.4, the opposite over the adjacent, 2.44. So that means theta is going to be inverse tangent of 9.4 divided by 2.44. That gives me, inverse tangent of 9.4 divided by 2.44. 75 point, what is it, the nearest degree? Yeah, 75 degrees. There's my answer. Okay, let's take a look at some more. 26. Okay, notice that 26 and 27 are like the same problem. So I'm just going to do this. Inverse sine of negative 0.75. See, like if I go to my unit circle, it's not going to have, you know, where is negative 3/4? It's not on there. Okay, so, but I can logically reason it through. You know, if I'm looking at the unit circle, where is the y value negative 3/4? Somewhere right, like right there, right? Because if this is 1/2 and this is 1, it's somewhere between 1/2 and 1. So the only places where along the unit circle I give this y value is right here and right here. Those are the only places where that y value exists. So right here or right here. Now it's giving me the negative 48.56 degrees, which is the answer to my 48.6 degrees, which is the answer to my first one, because that is between negative 90 and positive 90. But how does that relate to this one? This one in here where it's 180 to 270. Where is that angle? Well, remember, reference angles are the same. Okay, so I'm going to take 180 and I'm going to add on, you know, thinking about this full angle here, 180 plus the 48.6 degrees. Okay, remember, reference angles are always positive. So I'm going to take 180 plus 48.6 degrees, 228.6 degrees. All right. Okay. Let's try another one here. Notice again, exact same inverse cosine of 0.1. Okay. So now that is the only place. That is the only place where that cosine happens, right? Now think about it along the unit circle. Where is the x value? 0.1. Well, again, if this is 1/2 and this is 1.1 would be somewhere right here. So the only place along the unit circle would be right here or right there, right? So this is the angle that it's giving me, 84.26 degrees, which fits within this 4.3 degrees, which fits within this restriction. Okay, now look, 270 to 360. It's asking for 270 to 360. It's asking for that angle. It's like telling you, okay, there is one down there. Look for it. So if this is 83.4 degrees, this has got to be 83.4 degrees. So I'm going to take 360 and I'm going to subtract away 84.3 degrees, not 83.4 degrees. So we take here 360 minus 84.3 degrees, 275.7. That's my answer. Fits within that domain. Okay. And then let's try the word problem. Pilot of a small plane is flying at an altitude of 2,000 feet. I want to figure out what this theta is. Well, remember, if this is 2 miles, which is 10,560 feet, I know I want this here, which is, well, I don't want that. That's also 2,000. So here's my opposite and here's my adjacent. So tangent theta is equal to the opposite 2,000 over the adjacent 10,560. So theta is going to be inverse tangent of that fraction, whatever that is. Let's find that. Inverse tangent of 2,000 divided by 10,060 is 11 degrees. That's my angle of depression. Right. So hopefully this kind of cleared some stuff up. Look for, so the homework for the second day is a worksheet. So it's just more of the same problems. And then you get Friday off. Woohoo! All right. See you later.